Good morning, everyone. Welcome to Guru Brahma classes for JEE and NEET. We are in the chapter Ionic Equilibrium. Today in this session, we are going to learn about buffer solutions. In that buffer solutions, we are going to solve some problems which are asked in previous JEE mains. Let's start the session. So here is the question given. What is that question? 20 ml of 0.1 m H2SO4 solution is added to 30 ml of 0.2 m NH4OH solution. The pH of the resultant mixture pKb of NH4OH is given as 4.7. So when is this asked? This is asked in 2019, right? So what is given, what is asked, let us see. So first H2SO4 is given, right? So H2SO4 is mixed with whom? Is mixed with NH4OH. So when it is mixed with NH4OH, H2SO4 is acid. What is that? H2SO4 is acid and NH4OH is a base, weak base. So acid-base reaction happens. And what will be the product formed? NH4 taken twice, SO4 and H2O will be the product formed. What is this? Salt, right? Because as the mixed substances are what? Acid and base, there will be acid-base reaction happening. Okay. So now, if you want to calculate the concentrations of this, it is better to calculate in normality. Okay, here NH4OH, if you balance this equation, you will find 2 NH4OH. Okay, here H2SO4, N factor is 2. For H2SO4, N factor is how much? N factor is equal to 2. So, if I calculate normality, we know that molarity into N factor. That will be equal to normality is equal to molarity. How much is given? 0.1 molar. So 0.1 molar into N factor is equal to 2. So normality will be equal to 0.2 normal. Whereas for NH4OH, N factor is equal to 1. So normality is equal to molarity. So normality is equal to molarity. How much given? 0.2 molar given, right? So 0.2 molar. So 0.2 molar, then directly I can take it as 0.2 normal, right? So as the N factor is not equal to 1, we are calculating the concentrations in normality. And we know some formulae. What is that formulae? We know that normality is equal to number of equivalents by volume in liters. Then from this what I can write? Normality is equal to number of equivalents into, I can write a number of equivalents is equal to, what I can write? Number of equivalents is equal to normality into volume expressed in liters. Okay, if I express volume in milliliters, then I can write milli equivalents. Milli equivalents is equal to normality into volume in milliliters. Okay. So to express this milli equivalents, we can use the formula normality into volume in milliliters. Right? Now, how to solve this problem? Before reaction, what is present? So what is this? Before reaction, when they are taken individually. What is volume given here? Volume is equal to 20 ml and normality, now only we have seen that its normality is equal to 0.2. Milli equivalents, how many? Milli equivalents, MEQ means milli equivalents. Volume, normality into, what do we write? Normality into volume in milliliters. So normality how much given? 0.2 into volume 20 ml. That is equal to 4 milli equivalents. How many milli equivalents of H2SO4 are there? 4 milli equivalents. How many milli equivalents of NH4 are there? Milli equivalents here is equal to normality into volume in milliliters. Normality here already we have seen that it is 0.2. So 0.2 into 0.2 into 30 ml. Then that is equal to 0.2 into 30, 6 milli equivalents. Okay. Now this is all when before reaction. Let us consider after reaction. After reaction. That means reaction happened. Already we have studied that these two are acid and base. They two react with each other. When they react with each other, now you see 1 milli equivalent of acid always react with 1 milli equivalent of a base, and to form 1 milli equivalent of a salt. This is law of equivalence. That means here how many milli equivalents of acid are there? 4 milli equivalents are there. How many milli equivalents of base are there? 6 milli equivalents. So who will remain without reacting and who will completely react? H2SO4 completely reacts. So for 4 milli equivalents of H2SO4, you have 4 milli equivalents of NH4. Extra also is there. 2 milli equivalents extra is there. So what happens? These 4 milli equivalents react, completely react. That means what I can write? 4 minus 4 milli equivalents. So that there will be no H2SO4 remaining in the vessel, reaction vessel. Now among these 6 milli equivalents, how many react? 4 will react, because this 4 will react with the 4. How many remains? 2 milli equivalents will remain. According to law of milli equivalents or law of equivalents, we say that 1 milli equivalent produce 1 milli equivalent of the product. 1 milli equivalent of reactant produces 1 milli equivalent of the product. So how many milli equivalents of H2SO4 is completely reacting? 4 milli equivalents. So how many milli equivalents of ammonium sulfate will be found? 4 milli equivalents of ammonium sulfate will be found. Anyway, water is solvent. We are not bothered about that. So what is remaining in the container? In this container, reaction container, what is remaining? Finally, after reaction. So after reaction, in the container, what is present? What is present? NH4OH, how many milli equivalents? 2 milli equivalents. And NH4 taken twice, SO4 is present. How many milli equivalents? 4 milli equivalents. So now what is this? This is a weak base, and this is what? Salt of weak base with strong acid. What is that strong acid? H2SO4. So now this can be considered as a basic buffer solution. This is the configuration of basic buffer solution. Understood? Right? So in basic buffer solution, we know how to calculate POH, Henderson's equation. What is a POH? POH is equal to pKb plus log salt concentration by base concentration, right? Salt concentration by base concentration. Now POH can be calculated as, what is pKb here? pKb given as 4.7. What is that? 4.7. So 4.7 plus log salt concentration, how much? Here we have seen. Now what is the total volume on mixing these two? Final volume. but we can write total volume. Total volume is equal to 20 ml plus 30 ml, that is equal to 50 ml, right? Salt number of milli equivalents is how many? 4 milli equivalents. So I can write 4 milli equivalents by total volume 50 milliliters by base concentration is how much? 2 milli equivalents. 2 milli equivalents by 50 ml milliliters. Okay, then what you can do here? Milli, I am cancelling. 50 I am cancelling. So what you get is 4.2 plus log 4 by 2. Log 4 by 2 is equal to log 2. So 4.2 plus log 2 POH is equal to, then that is equal to 4.7 plus log 2 is equal to 0.3. Let me take it as log 2 is equal to 0.3. Then what you get is POH is equal to 5. Okay, and we know that pH plus POH is equal to 14. pH is equal to 14 minus POH, that is equal to 14 minus POH. We have calculated it as 5. Then what you get? 9. Okay, understood? So the answer will be 9. What is asked? The pH of the resultant mixture. The pH of the resultant mixture. So this type of questions frequently asked. We need to concentrate. We have to put acid base reaction happening, before the reaction, after the reaction, what is remaining in the solution. All those things are to be considered, right? Let us see the next question. So next question, question asked in 2020 examination. 2020 examination. So looking into this, what is the question? The question is, among these, an acidic buffer is obtained on mixing. On mixing these, acidic buffer should obtain. Let us see. The same process. What is that process? First option. Let us take first option. CH3COOH react with here all are for CH3COOH n factor. CH3COOH. Let us take n factor. N factor 1, because only one H plus can be replaced. For NaOH, n factor is equal to 1. HCl. What are the acids and bases given here? We are speaking 1. Okay, so for all these, n factor is equal to 1. So you can take molarity is equal to normality. You can consider molarity will be equal to normality. So CH3COOH is reacting with whom? NaOH to give you what? CH3COONA plus H2O. Right? So let us take milli equivalents here. So milli equivalents formula, normality into volume in milliliters. Here molarity is equal to normality, so I can take molarity as normality. Here let us habituate solving the problems in milli equivalents in that way, because we do not know when the n factor will change. So when the n factor is equal to 1, okay. If the n factor is not equal to 1, then it is better to solve the question in normality. So that is the reason why always we are taking normality into the context. Okay, so here normality is equal to molarity, so I can take it as 0.1 into volume is equal to 100 ml. So I get it as 10 milli equivalents. Here milli equivalents of NaOH is equal to 2C. Normality into volume 0.1 into 200. What is that? 200, right? So 200 ml. Then what you get is 20 milli equivalents. So this is what before a reaction. before reaction when they are taken in individual containers. So how many milliequivalents of NaOH are there? 20 milliequivalents. How many milliequivalents of acetic acid are there? 10 milliequivalents. So let us consider after reaction. So what happens when they are mixed? Okay, after mixing. After mixing. After mixing means after reaction. Here you have 10 milliequivalents, here you have 20 milliequivalents, and we know that 1 milliequivalent of acid, 1 milliequivalent of acid always react with 1 milliequivalent of base to form 1 milliequivalent of salt. This is the actual what happens when they react. Okay. So now after reaction, what is happening? Let us see. Here you have 10, here you have 20. So which is smaller? 10 is smaller. That will completely react. So 10 minus 10 milliequivalents. So what happens? 0 milliequivalents. Here 10 milliequivalents of NaOH react with 10 milliequivalents of acetic acid. So I can take it as 20 minus 10 milliequivalents. Then what do you get? 10 milliequivalents. So that it is remaining. After reaction, what is remaining in the container? NaOH is remaining, right? Now 10 is reacted, so 1 is reacted, so 1 will be formed. So how many milliequivalents of sodium acetate are formed? 10 milliequivalents of sodium acetate are formed. So what is there in the container? What is there in the container now? In the container, you will find a mixture of, in this reaction container, what is present? NaOH is remaining. NaOH 10 milliequivalents and sodium acetate COO how many milliequivalents? 10 milliequivalents. Is this a buffer solution? Not a buffer. Not a buffer. It is not a buffer solution. Why it is not a buffer solution? You are finding a mixture of strong acid. What is this? NaOH is a strong base. So strong base is there. So this is not a buffer, not a buffer. Okay, so let us go with the second option. So what is the second option? Again given the same 100 ml of 0.1 mA CH3COOH and 100 ml of 0.1 mA NaOH is given. So let us write the similar equation. So what is that? CH3COOH reacts with NaOH, giving rise to CH3COONA plus H2O. Okay, so let us take milliequivalents of CH3COOH is 0.1 N into 100 ml given, that is equal to 10 milliequivalents. Here milliequivalents of NaOH is equal to 0.1 into again 100, this is also given 100, 10 milliequivalents. So both are given. See, 0.1 into 100, this is also 0.1 into 100. Then what do you get? Initially we don't have these two. So this is what before reaction, before mixing, after mixing. So what is that? After reaction, what happens? After reaction, here also, you know the law of equivalence. So what happens? 10 milliequivalents completely reacts, so 0 remains. Here 10 milliequivalents completely reacts, 0 remains. And you know that 1 milliequivalent after reaction gives you 1 milliequivalent. Okay, so then what you get? 1 or 10 milliequivalents of sodium acetate is formed. So now what is there in the container? In the container remained, what is remained after reaction? CH3COONA is remained. How much is remained? 10 milliequivalents is remained. Can I consider this solution as buffer solution? No, it is just a salt solution, not a buffer. Not a buffer. Okay, so let us go with the third one, right? Third option. If you see third option, what are given? 100 ml of 0.1 m HCl and 200 ml of 0.1 m sodium acetate. Reaction is happening between HCl and sodium acetate. So when the reaction happens between these two, what do you find? We find that it is CH3COOH plus NaCl, right? So before reaction, what is that? Before reaction or before mixing, what is present? Milli equivalents is 0.1 into 100, that is equal to 10 milli equivalents, and sodium acetate milli equivalents is equal to 0.2 into 100, that is equal to 20 milli equivalents. Before reaction, we did not mix them. Now we are mixing that. So after reaction, after mixing, what happens? Here we have 20, here you have 10. So 10 completely reacts, 10 minus 10 milli equivalents, that gives you 0. Here 20 minus 10 milli equivalents, that is equal to 10 milli equivalents remained without reaction, remained unreacted. Then we know that if 1 milli equivalent react, 1 milli equivalent is completely formed, then what do you get? 10 milli equivalents of acetic acid is formed and 10 milli equivalent of NaCl is formed. So we are not bothered about this NaCl, we are bothered about this acetic acid. So what is remaining in the solution? So what remains in the container after reaction? In the container, if you see, in the container, what you find? You find CH3COONA 10 milli equivalents and CH3COOH also 10 milli equivalents. So what are these two? These two are one is weak acid, CH3COOH is weak acid, and CH3COONA is a salt of weak acid and a strong base. So this is the combination of what? Acidic buffer. Acidic buffer. So this combination gives you what? Acidic buffer. So is that what the question asked? Yes. The question asked is acidic buffer is obtained on mixing. So acidic buffer is obtained on mixing, this third option. What about fourth option? HCl and NaCl. So one is strong acid and another is salt of strong acid with HCl plus NaCl. So no reaction happens actually. So what is the answer? Third option is the answer. Let us see the next question. Coming to the next question. A student needs to prepare a buffer solution of propanoic acid and its sodium salt. Okay, with a pH of 4. The ratio of propanoate to propanoic acid required to make buffer Ka is given as 1.3 into 10 power minus 5 of propanoic acid. So already he is mentioning that it is buffer solution. Buffer solution. Okay. Now let us see propanoic acid. So propanoic acid reacts with CH3, CH2, COOH. What is this? Propanoic acid. Prop, 3 carbon atoms, carboxylic acid. When reacts with NaOH, then what do you get? CH3, COONA plus H2O. Okay. So what is the salt? This is salt of weak acid plus a strong base, because propanoic acid is weak acid and this is a strong base. So these two combination gives you acidic buffer. Okay, these two combination gives you acidic buffer, right? Now let us see propanoic acid. Propanoic acid CH3 CH2 COOH, and dissociation gives you CH3 CH2 COO minus H plus, right? This is the dissociation of weak acid, propanoic acid. Now if you write Ka for this, I write Ka is equal to dissociation constant of an acid. Dissociation constant of an acid gives you CH3 CH2 COO minus concentration into H plus and concentration by CH3 CH2 COOH concentration, right? Now if I write H plus and concentration, what do I write? H plus and concentration is equal to, rewrite the formula, I write it as Ka into CH3 CH2 COOH concentration by CH3 CH2 COO minus concentration, right? Okay. So for acidic buffer, we have acidic buffer. Acidic buffer is what? It's nothing but this is the container, right? In this container, what is present? CH3 CH2 COOH and CH3 CH2 COO Na. This is what? Acidic buffer. For acidic buffer, we have written some formula. What is that formula? Or directly we can, we have derived a formula, pH is equal to pKa plus log salt concentration by, what is that? Acid concentration. Or you can also write pKa plus log salt concentration by conjugate base concentration. So either you write salt or conjugate base. So what is that? Salt or conjugate base, both are same, right? So what is this? Salt, instead of salt we can write conjugate base by what? Acid concentration. Now I want rewrite again this formula. On rewriting this formula, what do I write? What do I get? CH3 CH2 COOH concentration by CH3 CH2 COO minus concentration is equal to H plus ion concentration by Ka, right? Now I want reverse of this because the question asked is in reverse. CH3 CH2 COO minus concentration by what is given? CH3 CH2 COOH concentration. This is asked. Then what do I get? I get it as Ka by H plus ion concentration. So Ka is given as how much? Ka is given as how much? 1.3 into 10 power minus 5. pH is given. See here, pH is equal to 4. H plus ion concentration will be equal to 10 power minus pH. That is equal to 10 power minus 4 molar. Okay. So Ka is given as 1.3 into 10 power minus 5. 1.3 into 10 power minus 5 by 10 power minus 4. That is equal to 1.3 into 10 power minus 5 plus 4. 1.3 into 10 power minus 1. 0.13. Okay. So this ratio is asked in the question. Let us see that question again. Okay, CH3COO minus by CH3CH2COO. So this concentration is, this ratio is asked. So the ratio, what you are getting? 0.13, second option. So when is this given? 2022. Okay, let us see next question. So class 12 students, when is class 2022, were asked to prepare 1 liter of buffer solution of pH is equal to 8.26. Okay, so what is given? You have to prepare buffer solution of pH is equal to 8.26 by their chemistry teacher. The amount of ammonium chloride, what is asked? Amount of ammonium chloride is asked, that is mass or weight, to be dissolved by the student in 0.2 molar ammonia solution. What is given? Ammonia concentration is given as 2 molar. To make 1 liter of buffer, so volume of buffer given as 1 liter, and pKb is given. pKb of NH3 is given as 4.74. Okay, the remaining molar masses are given. So this is the question asked. What you are finding? There is one weak base. What is this? Weak base, and this is salt of weak base with a strong acid. So it is a what buffer solution? Basic buffer solution. Basic buffer solution. So first you have to understand that it is basic buffer solution. So in this basic buffer solution, what you can write? NH3 reacts with HCl to form NH4Cl, right? NH4Cl. So this is weak base, salt of weak base with a strong acid. Okay, and to calculate pOH of basic buffer, we have derived a formula. And what is that formula? pOH of basic buffer is equal to pKb plus log salt concentration by base concentration. Okay, here I can write pOH is equal to pKb plus log salt is NH4Cl concentration by NH3 concentration. Okay, now what is given? pH is given in the question. pH is given, but here what do we want? pOH we want, and we know that pH plus pOH is equal to 14. pOH is equal to 14 minus pH. 14 minus 8 point, much given 8.26 given. 8.26, that is equal to 5.74 we get. What do we get? pOH as 5.74. So I can write it as 5.74 is equal to, right? Then what is pKb given? 4.74. 4.74 plus log NH4Cl concentration by NH3 concentration. How much given? 0.2 molar. 0.2. Okay. So if 4.27 comes this side, 5.274 minus 4.74 is equal to log NH4Cl concentration by 0.2 molar, that is equal to 1. What do you get? So log NH4Cl concentration by 0.2 is equal to 1. I can write it as log NH4Cl concentration by 0.2 is equal to 1 can be written as log 10. Log cancel. Then what do you get? NH4Cl concentration is equal to 10 into 0.2 molar. that is equal to 2 molar water NH4Cl. And we know that molarity is equal to number of moles by volume expressed in liters. That is equal to weight by molecular weight by volume expressed in liters. Already molarity, now we have calculated for NH4Cl. What is molarity? Molarity is 2 molar. 2 molar is equal to weight by molecular weight of NH4Cl, already given in the question. What is that? 53.5 grams. How much? 53.5. So 53.5 volume of the buffer solution it is given. Volume of this NH4Cl present in the buffer solution. What is the volume of buffer solution? 1 liter given. So weight is equal to 2 into 53.5 grams, that is equal to 107 grams. So weight of foam NH4Cl, okay, in the buffer solution is equal to 107 grams. Understood? So follow each and every point, each and every step I am writing. Let us see. First of all, we need to understand the question, then we have to proceed. Until and unless we understand the question, it is not possible to solve the question. Okay, right. Let us see the question. Next question. So what is that next question? See, assertion and statement 1 and statement 2 type of question is given. Very recent examination question is given. What is that? Statement 1 and statement 2. A buffer solution is a mixture of salt of an acid. Actually, it is weak acid or a weak base. Okay, we shall consider acid or base mixed in any particular quantities. So, is the statement correct or wrong? We have studied the for acidic buffer. Acidic buffer, let us take. So, acidic buffer, what is pH range? pH range is equal to pKa plus 1 to pKa minus 1. Okay. So only between this pH range, that is pKa plus 1 to pKa minus 1, that buffer effectively works as buffer. So what is pH range? Range of pH in which buffer works effectively. Range of pH in which buffer solution works effectively. What is the meaning of this buffer solution work effectively? Buffer solution working as buffer solution. It will properly work as buffer solution between this pH range. What is that pH range? pKa plus 1 to pKa minus 1. So when can this happen? When this can happen when salt concentration to acid concentration is equal to 10:1. We know that formula pH is equal to pKa plus log salt by acid concentrations. Then what do you write? pH is equal to pKa plus log 10 by 1. So pH is equal to what you get? pKa. pKa log 10 is equal to 1. So did you get this? Yes, we got this. And range is pKa plus 1 to pKa minus 1. If salt concentration to acid concentration is equal to 1 by 10, then pH is equal to pKa plus log salt by acid. Then what do you get? That is equal to pKa plus log 1 by 10. That is equal to pKa plus log 10 power minus 1. That is equal to pKa minus 1 pH. Okay. So only if the salt concentration and acid concentration ratio 10 is to 1 to salt concentration to acid concentration 1 is to 10, it can act as buffer. Here in the statement given, at any particular quantities, no, it should be particular quantity. What is that? Salt to acid concentration ratio must be from 10 is to 1 to 1 is to 10. Then only it can act as buffer solution, proper buffer solution. In the same way, if you take basic buffer solution, it can act as proper basic buffer solution if the salt to base concentration is from 10 to 10 minus 1, then only it can act as proper basic buffer solution. You cannot take any ratio. You cannot take any ratio. It should be ratio from 10 to 10 power minus 1. It is also from 10 to 10 power minus 1. Then only they can act as proper buffers. Are you getting? So the statement is wrong. Now statement 2. Blood is naturally occurring buffer solution whose pH is maintained by H2CO3 and HCO3 minus. Okay. So let us take blood. Natural buffer. Okay. Natural buffer solution. Human blood, let us take. In this human blood, what is present? So human blood, let us take human blood. In the blood, there is H2CO3 and HCO3 minus. What is this? This is a weak acid, and this is what a conjugate base of that weak acid. So this mixture is acidic buffer, because weak acid, no, acidic buffer solution. So here humans, we drink water. When you drink water, what happens? The blood gets diluted. When blood gets diluted, does it pH change? No. So pH of human blood must remain constant. If you suddenly drink water, it gets diluted. Does the pH change? No. Why? Due to these two concentrations, because there is blood is acting as a buffer due to the presence of carbonic acid and carbonate ion, bicarbonate ion. Carbonic acid and bicarbonate ion. In our blood, there is a mixture of H2CO3 and HCO3 minus. They act as the acidic buffer. The property of a buffer solution is to resist the change in pH. We eat acidic foods, we eat basic foods. Though we eat acidic foods, basic foods, though you drink water, so whatever you do, our blood pH is not changing, because blood is acting as a natural buffer which resists the change in pH. This is acting as a buffer due to the presence of weak acid, that is H2CO3 and bicarbonate ion. These two concentrations will help to resist the change in pH and make the human blood does not change in the pH. So what will be the answer here? So blood is naturally occurring buffer solution whose pH is maintained by H2CO3 and HCO3 minus concentration. So this statement is correct. So statement 1 is wrong and statement 2 is correct. Statement 1 is false and statement 2 is true. So this is the correct answer. Understood? Right? So these are some questions which are asked in JEE main previously. We shall see some more questions in the next lecture. Let us wind up this lecture and let us meet again in another lecture, right? Thank you for watching.